Students, do you remember last time discussed about the new chapter, Unit 4, known as Chemical Kinetics? You know what I mean by chemical kinetics means? Chemical kinetics deals about the rates of chemical reaction. The other one is rates. Rate is equals to changing concentration with changing time. Also discuss about factors that affect the rates of chemical reaction, like nature of reactant. The second one is surface area of solid reactants. Again, the third one is concentration. In today's lesson, discuss about the other factors and the other subtopics for in chapter 4. The fourth factor is temperature of reactants. Temperature is a factor that affects for chemical reactions. Therefore, an increase in temperature increases the rates of a reaction. Because the temperature increases, the average kinetic energy of the reactant particle increases. Which means what? When the temperature increases, the reactant particles are more collide, more contact. Because of more contact, the rates of chemical reaction, it increases. This is because the average kinetic energy of the reactant particles increases. Therefore, temperature is a factor. The other one is a catalyst. The presence of a catalyst affects the rates of chemical reaction. The presence of a catalyst, effect of catalyst on the rates of the reaction. A catalyst is a substance that changes the reaction rates by changing the activation energy. Students, you know what I mean by activation energy? Activation energy is the minimum amount of energy required to start a given chemical reaction is known as activation energy. Therefore, catalysts affect the activation energy. Therefore, there are two types of chemical catalysts. One, positive catalyst. The other one is negative catalyst. Positive catalysts speed up of chemical reaction by lowering the activation energy level. Negative catalysts are sometimes known as inhibitors, slowdowns of chemical reaction. Therefore, positive catalysts speed up of a chemical reaction by lowering of what? The activation energy level. The other one is negative catalysts. Negative catalysts is what? Slowdowns of a chemical reaction by lowering what? The activation energy level. Look diagrammatically. This is the energy level diagram for reactant and product. Look, this one is energy. Let's take this one is the reactant position. Look this diagram. This is progress of reaction. Progress of reaction. This is energy. Let's take this one is a reactant. This is product. Now, this point, this one is known as EA. EA means activation energy. Let's take, when reactant produces product, this is the energy barrier. This is known as activation energy. By using so positive catalyst and negative catalyst, changes EA value. For example, by using so positive catalyst, the diagram is look like this. This is activation energy level. By using so what? Positive catalysts. Maybe by using so negative catalyst, the graph look like this. This is by using so what? Negative catalyst. Therefore, negative catalyst increases the activation energy level. The higher the activation energy level, the slower the reaction. Positive catalysts speed up of chemical reaction by lowering of what? Activation energy level. Therefore, positive catalysts speed up of chemical reaction. Negative catalysts slow down of chemical reaction. Therefore, catalyst is what? Catalyst is a factor. Look this reaction. 2SO2 or sulfur dioxide gas plus oxygen gas, it gives sulfur trioxide or 2SO3 gas. In this case, The catalyst can be used is V2O5, vanadium pentaoxide. The physical states of vanadium pentaoxide is solid. Therefore, V2O5 can be used as a catalyst. This is positive catalyst. What is the purpose of V2O5? The purpose of V2O5 is a speed up of chemical reaction by lowering of EA. Therefore, the purpose of V2O5 or vanadium pentaoxide is lowering of the activation energy level, speed up of a chemical reaction. Again, V2O5 is a heterogeneous catalyst. V2O5 is already solid. The state of the reactant is gas. What is the physical state of the reactant? Gas. What is the physical state of the catalyst? Solid. Is it the same physical state? No. Therefore, V2O5 is a heterogeneous catalyst. Another example, OCl minus aqueous plus I minus aqueous. It gives OI minus aqueous plus Cl minus aqueous. In this case, the catalyst can be used as OH minus. OH minus is as inhibitor. You know what I mean by inhibitor means? Inhibitor means negative catalyst. Negative catalyst. Therefore, OH minus is slow down of a chemical reaction by increasing the activation energy level. V2O5 decreasing the activation energy level. OH minus is increasing the activation energy level. When the activation energy level is increases, the rate of the reaction will be decreases. Therefore, OH minus is as inhibitor or as a negative catalyst. In this case, OH minus is a homogeneous catalyst. Homogeneous catalyst. Why homogeneous catalyst? Because the state of the reactant, look, aqueous. Aqueous means in water. OH minus is again aqueous. The physical states of OCl minus, I minus, already the physical states of the reactant, aqueous. Again, OH, aqueous means, by the way, in water. In water already liquid. OH minus aqueous. The same physical state. Because of the same physical state, this catalyst is homogeneous catalyst. Therefore, catalysts affect the rates of chemical reaction. The other point, theories of reaction rates, especially concentration and collision theory. Simply, the number of collision increases or the concentration increases, the number of collision increases. Collision means the contact between solute and solvent. The contact between reactant substances. When the contact between the reactant substances increases, the number of collision increases. The number of collision increases, the rates again it increases. Therefore, rate is what? Directly proportional to the number of collision. The higher the concentration, the higher the contact. The higher the contact, the higher the collision within a given period of time. Simply, concentration and collision theory is directly proportional because concentration increases, the contact between the reactant particle increases, the contact increases, the collision increases, the collision increases, rate of chemical reaction increases. Simply, rate is directly proportional to the number of collision. According to collision theory, more collisions there are, the faster the rate of the reaction. Yes, the more collisions there are, the faster the rate of the reaction. Which means all collisions, by the way, all collisions are not give the desired products. Look, according to collision theory, the more collisions there are, the faster the rates of the reaction would be. However, not all collision between reactant species result in a reaction. That means all collisions are not give the desired product. Because collision, again, classify into two types. One, effective collision. The other one is ineffective collision. Effective collisions are collisions that gives the desired product, the favorable product. Ineffective collisions are collisions not gives the desired product. Therefore, the collision must be in proper orientation. Postulates of collision theory. This is summary for the collision theory. For a reaction to occur between reactants, 3 criteria must be fulfilled or satisfied. 1, the particles of the reactant species must collide. The reactant must be collide. When we give a product, the reactant species must collide. This is the first procedure. This is the first theory. The second one, the particles of the reactant species must have proper orientation. The same arrangement or the proper orientation is very necessary. Simply, all collisions are not give the desired product. Therefore, proper orientation means effective collision. 3, the particles of the reactants must collide with energy greater than or equals to the energies of activation energy. The third one is the energy of the reactant species must be greater than or equals to the energy of activation energy. This is all about the postulates collision theory point of view. The other point here is transition state theory. By the way, look diagrammatically. Let's take a simple diagram. This one is energy. This is progress of reaction. Progress of reaction. This is reactant. This one is product. This is TS or transition states. The point or the peak one. This one is what? Transition states. Transition state theory is also referred to as activated complex theory. Is short-lived species? Yes, look. A reactant, it gives product. But before product can be formed at the intermediate position, a transition state can be formed. Therefore, transition state is short-lived species. This is short-lived species. Let's take the reactant, for example, A plus B. It gives C. Before the production of C, A and B present here. But A and B present from this position, this is transition state. This one is short-lived species. Temporary format, yes. In the transition state, it is temporary format. Again, high energy state species. Yes, this is in higher energy level. By the way, look this diagram. Products are at the bottom here. Reactants are from this position. This is exothermic diagram. This is transition state. The energy of transition state is in higher order, in higher position. Therefore, this is higher energy level position. Because of the higher energy level, transition states are unstable. Therefore, temporarily formed by the collisions of the reactant molecule before they form products. Transition states are formed before the formations of what? Products. This is the transition state. Simply, transition state, it is short-lived species, higher energy state species, temporary formed, and unstable. Rate equation or rate law. Again, order of reaction and rate constant. Rate law and rate constant, the rate of chemical reactions depend on the concentrations of one or more of the reactants. An equation that relates reaction rate to the concentrations of reactants is called the rate law for the reaction. The rate of chemical reaction, rates of chemical reaction depends on the concentrations of one or more reactants, not products. Rate depends on the concentration of one or more reactants. An equation that right with rate is known as rate equation. For the general reaction or for a simple reaction, A converted into B. A is converted into B. The rate law, already A is what? Students, what is A? A is reactant, B is product. Therefore, rate expression for this one is rate, first rate directly proportional to the concentration of A raised to X. Rate directly proportional to the concentration of A raised to X. Because rate depends on the concentrations of one or more reactants. But in this case, how many reactants? One reactant, only A. Therefore, rate of reaction, it depends on only A. Now, rate directly proportional to A raised to X. Therefore, rate is equals to K A the power of X. A the power of X. R means rate. K, rate constant. K is the rate constant for the reaction. Students, what mean by this one? Square bracket. Yes, concentration. This one is concentration. What about A? In this case, A indicates the concentration of the reactants. Another point, X. X is the order of the reaction. The order of the reaction. K, the rate constant. X, the order of the reaction, and it is determined from experimentally. By the way, X is determined from experimentally. X is not stoichiometric coefficient. X is not similar to coefficient. For example, 2A converted into B, rate is equals to K A the power of X. But in this case, X is not 2. X is not similar to stoichiometric coefficient. X is determined by experimentally. X is determined by experimentally. For the general reaction, the previous one is for a simple reaction, A. Look at this one. This is a simple equation, A plus B. It gives D plus E plus F. What is a reactant in this case? A and B are reactants. D, E, and F are products. Students, rate of chemical reaction depends on the reactant A and B or the product D, E, and F. Which one is correct? Thank you. Rates of chemical reaction depends on the concentrations of this capital letter A and capital letter B, because rate depends on the concentrations of one or more reactants. Where A, B, D, E, and F, small letter, look, small letter A, small letter B, small letter D, this one, small letter E, and small letter F are balancing coefficients. The rate law expression for this reaction is rate is equals to K times A the power of X, B the power of Y, X and Y. But X is not A, Y is not B. This is simply the rate expression. Rate directly, yes, rate is directly proportional to capital letter A and capital letter B. Why capital letter A and why capital letter B? Because capital letter A and capital letter B indicates what? The concentrations of the reactants. Rate is not depends on D, E, and F. An overall order of reaction, by the way, the order of A is how much? X. The order of A is X. The order of B is Y. What is the order of the reaction? What is the order of overall? The overall order is X plus Y. X plus Y is the order of the reaction. Simply, X plus Y, the order of the reaction. The order of the reaction, or simply X, may be 0. 0 is possible. Not only for X, X and Y. Simply the order of the reaction. 0 is possible. Negative integer possible. Positive integer possible. Fraction is possible. This is order of reaction, but X is not stoichiometric coefficients. Determination of rate law using the method of initial rates, because order is not determined simply by using of a coefficient. X is determined by experimentally. Look by using of some examples. Determination of rate law using method of initial rates. Example 1. For this reaction, 2N2O5, it gives 4NO2 plus O2. The initial concentrations and the corresponding initial rates for the two experiments are as follows. Please, students, in this case, rates of chemical reaction depends on which one? Product or reactant? Already it's, it depends on only the concentrations of N2O5. The experiments are given. Look this experiment. Already you know the reaction. The reaction is this one. 2N2O5. 2N2O5. It gives 4NO2 plus O2. The very important point is 2NO25. The reactants are N2O5. How many experiments are given? 2 experiments are given. Look carefully, this one. Initial N2O5 concentration. This symbol, square bracket, is concentration. This 0 symbol in subscript is initial. Initial concentrations of N2O5, only reactants. Initial rates. This is concentration, usually molarity. You know rates, molar per second. What is given? In experiment 1, the initial concentrations of the reactant is 1 times 10 raised to minus 2. In experiment 2, 2 times 10 raised to minus 2. Initial rates for experiment 1 is 4.8 times 10 raised to minus 6. Experiment 2, 9.6 times 10 raised to minus 6. By indicating this diagram or this table, find the rate law for the reaction. The first question. What is the rate law for the reaction? For this one. What is the rate law? The second one, calculate the rate constant. Or rate constant means, by the way, K. K. Calculate K. What is the value of K? The third one, by using again, this table, what is the unit of K? Because K is already unit rate constant. Any rate constant, its own unit. Therefore, what is the unit of this rate constant? Look the first one. The first point here is, for one reactant, because already the reactants are what? 2N2O5. It gives products, because the products are not necessary for this equation, because rate depends only the concentration of the reactant. NO2 plus O2 is as such not necessarily. Therefore, to NO25 it gives product. Always, for the rate determination, use this one. Select 2 experiments. Because in this case, the number of experiments is 2. Select 2 experiments, which is R1 and R2. R1 and R2 means, for example, R1 over R2 is equals to C1 over C2, the power of X. Because K is already constant. What is R1? 4.8 times 10 raised to minus 6. What is R2? 9.6, 10 raised to minus 6. What is C1? 1 times 10 raised to minus 2. What is C2? 2 times 10 raised to minus 2. Therefore, look, take 2 experiments. R is equals to K N2O5, the power of X. Already K is constant. For 2 experiment, R1 over R2 is equals to C1 over C2, the power of X. Again, it is possible. R2 over R1 is equals to C2 over C1, the power of X. Again, it is possible. If C1 over C2, R1 over R2, C2 over C1, R2 over R1 is possible. Therefore, R1 over R2 means, R1 means rate 1, R2 rate 2. C1 is the concentration of the first one, C2 is the concentration of the second one. Therefore, 10 raised to minus 2 cancelled by 10 raised to minus 2, which is already 1 over 2. This is cancelled. 4.8, 9.6 means by 4.81, by 4.82, 1 over 2. Therefore, 1 over 2 is equals to 1 over 2 the power of X. What is X? Already this is, the power is 1. What is X? X is equals to 1. X is equals to 1. Therefore, what is the order of this reaction? The order of the reaction is 1. Therefore, the rate law is R is equals to K N2O5. The power of 1 already is 1. First order reaction. The second point here is, what is the value of rate constant from this one? What is the value of rate constant means? Determine K. What is K? K is equals to R over concentration of N2 O5 the power of x. R is equals to k n2O5 x. K is equals to R divided by n2O5 the power of x. But already x is equals to how much? X is equals to 1. Simply k is equals to R over concentrations of n2O5. By using this formula, determine k. Which rate? Rate 1 or rate 2 is possible. But if rate 1 is used, this one must be concentration 1. If rate 2 can be used, this one is concentration 2. But the value is the same. Look, B. K is equals to how much? R is equal to K N2O5. You know, this is first order. By using this equation, by rearrangement, K is equals to R over N2O5, the power of already 1. This is, let's take experiment 1. Experiment 2 again is possible. 4.8 times 10 raised to minus 6. Which one? Rate 1. 1 times 10 raised to minus 2. Concentration 1. This is 4.8 times 10 raised to minus 4. Because already K is constant. For constant, R1, C1, R2, C2, it gives 4.8 times 10 raised to minus 4. The third one is, what is the unit of rate constant? Look, what is the unit of rate constant? Already it's known. Per second. Per second. By the way, always rate determined by, always rate constant unit determined by this formula. Look, rate is equals to K a the power of x. By using this equation, determine the units of K. K is equals to R over a the power of x. Students, what is the unit of R? What is the unit of rate? Previously discussed, which is concentration, already molarity, per second. This symbol indicates what? A square bracket indicates concentration. Concentration, already molarity. From this one, already first order equation. For first order equation, this one is 1, already 1. Therefore, molarity cancelled by molarity. What's left? Per second. Therefore, always the unit of first order reaction is a reciprocal of time. Simply, a reciprocal of time is 1 over time. 1 over time is per second, per minute, per hour is possible. Any first order reaction. If this reaction is second order reaction, look this one. For second order reaction, K is equals to R a the power of 2. If second order reaction. R is what? Molar per second, because the unit of rate is molar per second. What is A? Concentration of reactant, which is molarity squared. Now in this case, 1 molarity cancelled by 1 molarity. What is the final unit? Per molarity per second. Per molarity per second. This is the unit of rate constant for second order reaction. Again, if the order of the reaction is 0, for third order reaction, this is for x is equals to 2. Let's take x is equals to 0, because 0 order is again possible. K is equals to R over a the power of 0. You know a the power of 0, already 1. Therefore, this is simply molar per second. This is a unit of what? This is a unit of rate. Which order is similar to rate? 0 order. The unit of 0 order and the unit of rate of reaction is the same. By using this formula, determine the unit of rate constant. For simply A converted into products, rate is equals to K a the power of x. You know x is 0 order, first order, second order is possible. Look this general expression for, by using soft table, for 0 order reaction, first order reaction, and second order reaction. The first point here is, if A naught is doubled, what happens? X is 0 order. For 0 order, the concentration is doubled. Look for their order. Rate is equals to K. For their order is what? A the power of 0. If A naught means what? Initial concentration. Initial concentration is doubled. Initial concentration doubled means this value is K, already doubled means to the power of 0. To the power of 0 is how much? 1. Therefore, in this case, rate is equals to K. Rate is unchanged. Why rate is unchanged? Because their order. What about the initial concentration is tripled? The initial concentration is tripled. If the initial concentration is tripled, rate is equals to K at the power of 0. Tripled means K 3 the power of 0. 3 the power of 0 is again 1. Therefore, K. Rate again K. Simply, for their order reaction, the initial concentration is doubled, rate is unchanged. The initial concentration is tripled, rate is unchanged. For zero order reaction, rate does not change. Similarly, for first order reaction, x is equals to 1. X is equals to 1 means R is equals to K a the power of 1. By the way, doubled means what? R is equals to K to the power of 1. To the power of 1 is how much? 2. 2 times K. 2K. Rate is changed. Yes, changed by doubled. Therefore, rate is doubled. Simply, R is equals to, already K is constant, to the power of 1, 2 times of K. Tripled. Tripled means R is equals to K a the power of 1. K times triple means 3 to the power of 1, which is 3K. Similarly, for second order reaction, R is equals to K a the power of 2. Doubled means to the power of 2. To the power of 2 is what? Quadrupled. Second order reaction, tripled means 3 to the power of 2. R is equals to K 3 to the power of 2. 3 to the power of 2 already rates 9 times increases. This table simply indicates for zero order reaction, the concentration increases, decreases, rate is unchanged. Rate is constant. Which order of reaction is not depends on concentration? Zero order reaction, because any number the power of 0 is already 1. For first order reaction, the concentration is doubled to the power of 1, rate is doubled. The concentration is tripled, rate is tripled. For second order reaction, concentration is doubled, rate is quadrupled, because to the power of 2. Concentration is tripled for second order, 3 to the power of 2, rate is 9 times increases. This is all about today's lesson. Thank you, students. Until next time, goodbye.